So the number of significant figures in a result is the number of figures that are known with some degree of reliability. This sometimes depends on the measurement that is being taken. For example, if we have length of a pencil is measured with a ruler whose smallest division is 1 millimeter. Here's the example. So the smallest division is 1 millimeter. As you can see here, let's say 14 to 15, it's all in centimeter. Okay. So since the smallest division is 1 millimeter, then the measurement is only accurate to the nearest millimeter, or 0.1 centimeter. Therefore, we can say, so the length of the pencil, or this pencil, is 14.6 centimeter. But we cannot say the length of the pencil is 14.63. Because how can you show sure that it's 14.63? Why not 14.67 or 68? Because the smallest division is 1 millimeter or 0.1 centimeter. So we cannot use digit 3 or something else behind after digit 6. The length of the pencil can be given correct to 3 significant figures. 3 significant figures. So 1, 2, 3 significant figures. But cannot be given correct to 4 significant figures. Here are some rules for significant figures. All non-zero digits are significant. So all non-zero digits are significant. For example, we have 2,578 kilogram. Let's say we have a units here. This has 4 significant figures. We can count it here: 1, 2, 3, and 4 significant figures. Once again, all non-zero digits are significant. The second one, zeros between non-zero digits are significant. The example, we have 20,004 kilometers. This has 5 significant figures because zeros in between the non-zeros. These zeros are significant. So we have 1, 2, 3, 4, and 5. 5 significant figures. Remember, the first one, all non-zeros digits are significant. If you have 0, the zeros between non-zero digits are significant. The third one, zeros to the left of the zeros to the left of the first non-zero digit are not significant. Example, we have 0.023 gram. This number, it has two significant figures because zeros to the left of the non-zero digit, the first non-zero digit, the first one is 2. So 0 to the left, they are not significant. So we only consider 2 and 3. We have two significant figures. The fourth one, zeros placed after another digits, but to the right of the decimal point are significant. Remember, 0 placed after other digits, after, but to the right of decimal points are significant. Example, if we have 0.1, 0 milliliter. After other digits, in this case 1, but to the right, not to the left. To the left is they're not significant. So the first 0 here, it's not significant. 0 to the right of the decimal point are significant. So we have 3. 1, 2, 3. So 0.100 milliliter has 3 significant figures. Example, write down 24.31 correct to two significant figures. So remember this, the first rule, all non-zero digits are significant. Therefore, everything here are significant. 2, 4, 3, 1. We have 4 significant figures for this number. But since we need to write down correct to 2 significant figures, so it starts from the first one, 1, and then 2. We need to look at the third. Since it's 3, which is less than 5, remember 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the digits. We divide it into 2, less than 5 and greater than 5, or n5. Since we have 3, therefore it remains 24. So it's 24. We round it down. The second one, zeros between non-zero digits are significant. So in this case, 1005, we have 4 significant figures. But we need to write it down correct to 3 significant figures. So it's 1 significant, 2 significant, the third one. And then we look at the fourth digit. Since it's 5, therefore this number, we need to add 1. It becomes 1010. Because we have 1000 here, it's not 101. It's 110. We round it up. The third one, write down 0.2981, correct to 2 significant figures. For this number, 0.2981, we have 4 significant figures. 1, 2, 3, and 4. Because 0 to the left of the first non-zero, it's not significant. So the significant digits are 2981. We have 4 significant figures. We need to round it correct to 2 significant figures. Therefore, here's the first one, here's the second one, to 2 significant figures. Look at the next digit. It's 8. Since 8 is greater than 5, 8 is greater than 5, we need to round it up. This no longer be 9, so we add 1. 29 plus 1, it becomes 30. But it's not 30, it's 0.30. Okay? Therefore, the answer is 0.30. We have 2 significant figures. But then, why we don't write it as 0.3? If we write down 0.3, well, we can say 0.30 is equals to 0.3. But then, for 0.3, it has 1 significant figure, just 3. Because 0 to the left, it's not significant. We only have 1 significant figure, sorry. It is asked for 2 significant, so we need to add 0 here. So the answer is 0.30. Estimation. An estimate of a quantity is an approximation that is usually used to check the reasonableness of an answer. To estimate the answer to a calculation, round all the numbers involved to 1 significant figures, without S, significant figure. Example. So we have a theater has 98 rows. Each row has 23 seats. Estimate the number of seats in the theater. We need to round this to 1 significant figure. It becomes, since the next number is 8, therefore, we need to add 1 to the 9. It becomes 0 and then 1. It's 98. It doesn't become 10. 100 it is. That's for the first one. Each row has 23. So we need to round this 23. The next digit is 3. Therefore, we need to round it to 20. It remains, we keep the 2. 20 now. To estimate the number of seats, we need to multiply. Therefore, 10 times 20 equals to 2,000 seats. That's the answer. So remember, round 98 to 1 significant figures, it becomes 100. And then round 23 to 1 significant figure become 20. Then we multiply. You know what? The exact answer, it should be 98 times 23. If we calculate, wait a minute, it's 2,254 seats. Remember, we only need to estimate. So here is our estimation. 2,000 seats. Point to remember, we always have to round all number that involved to one significant figure. Let's go to the next example, number 2. Estimate the average of a car that travels 527 kilometers in 6 hours. Ooh, finding speed. Speed equals to distance, I will label it as S, divided by time. Therefore, what we need to do, we need to round 527 to one significant figures. It becomes 500. And then 6 hours to one significant figures. It's already 6. Well, for this case, I think it's better if we round 6 down to 5. Just to make the division our calculation, division calculation, easier. And we go back here, it's 500 divided by 5. Don't forget the units. So it becomes 100 kilometers per hour. Answer should be 527 divided by 6. It should be 87.8 kilometers per hour. Next, error and percentage error. The difference between an estimated or approximated value and the exact value is called the error. How to find error? Here is the formula. How to find error? It is the difference between estimated with exact value. So it should be VA, where VA is the approximated value or our estimation, minus VE, the exact value. I need to add this. Oops. This is an absolute VA minus VE. What does it mean by this two bar? It means whatever the value between the bar, the result will always be positive. Always. Let's check the example. Number 1. Maria and Moses each went to a different concert. In the concert that Maria attended, there were 1,450 people, and Maria estimated that there were 1,300 only. Let's calculate the errors that Maria made in their estimation. Remember, error, Maria. Error equals to absolute value, VA minus VE. The estimation or approximate value is 1,300. That's what Maria estimated. Minus 1,000, here's the real one, 450. Therefore, we have 150. It should be negative 150 since we have absolute notation. The answer become positive. So it's 150. That's the error. That's the error that Maria made. Now goes to Moses. In the concert that Moses attended, there were 1,950 people. But then Moses estimated that there were 1,800 or 1,800. So for Moses, the error equals absolute VA minus VE. The estimation or the approximation value, it's 1,800. And the real value or the exact value is 1,950. It becomes negative 150. Once again, since we have an absolute notation, the answer becomes positive. So 150, 150. Continue to the percentage error. Now we need to find the percentage error. Finding the percentage error, we need to use the error divided by exact value multiply by 100, and then we put percent. Since the error is absolute value of VA minus VE, absolute value, divided by VE, and then times 100%. So here is the formula for finding percentage error. Let's go to the example. The size of angle M is 125.7. Solomon measures M with a protractor as 126. So it seems like 126 is the approximation value, because maybe in his protractor it's not that detailed. So he rounded to 126 degree. 125.7 degree is the exact value. Therefore, let's see the percentage error that Solomon made in measuring the angle. Therefore, percentage error equals to absolute value VA minus VE divided by VE times 100%. VA is 126 degree minus 125.7 degree divided by VE 125.7 degree, multiply 100%. Using our calculator, we will find 126 minus 125.5, it's 0.3 over 125.7 times 100%. In calculating this, do not include the percent. So just 0.3 divided by 125.7, and then we multiply by 100. It becomes 0.238663484%, because 0.23886638484 is the result of that calculation. So the percentage error that Solomon made is 0.238663484. In IGCSE, you have to round it to 3 significant figures. So 1, 2, 3. We'll look at the 4th significant figure. Since the 4th one is 6, so we need to round it up. It's no longer 8, it becomes 9. So it's 0.239%. 3 significant figure.